Okay, I'm just going to talk you through the probability assessment that you did last week. The idea is that you watch the video and correct your answers or mark your answers correct, depending on whether you got them right or not. And if you didn't get anything right, you follow the video and work out what you've done wrong, hopefully, and correct your answers. After we've gone through the 7 questions, there's another set of very similar questions, and the idea is that you do, if you got question 1 wrong in the assessment, then you do question 1. If you got question 2 wrong, you do question 2, and so on. So you get some more practice on the stuff that you need to practice. So we start with question 1. Carlos rolls a fair 6-sided dice on a probability scale marked with an X, the probability that he rolls a 5. So if he rolls a 5, there's only 1 5 out of 6 faces on the dice. That's a 1 in 6 chance. And we just need to figure out where 1/6 would fall on this probability scale. So if you think of a half as being 3/6, we could kind of split the first half of the scale into 3 equal intervals. And 1/6 would be at the first marker, the first interval. Okay, and if we went on, we could then we'd have 3/6, 4/6, 5/6, and a whole is 6/6. So 1/6 should be about there. Okay, question 2. Max is wearing exactly 1 colour. The probability he's wearing blue is 0.4. The probability he's wearing green, 0.15, and the probability that he's wearing red is 0.25. The probability that he's wearing blue or green, when you see the word or in a probability question, you add the probabilities together. So you want the probability of blue added to the probability of green. So probability of blue is 0.4, green is 0.15, add them together, you get the probability of blue or green is 0.55. Question B, probability always adds up to 1. If we add up 0.15, 0.4, and 0.25, this doesn't come to 1. So we need to subtract the total of those probabilities from 1 to work out the probability that Max is not wearing blue, green, or red. That leaves us with 0.2. And the last question, probability of not wearing red, again, always adds up to 1. So the probability that he is wearing red is 0.25. Not wearing red is 1 take away 0.25, which equals 0.75. Okay, question 3. Most people did very well on the first question, but people went about the second question slightly different ways. So we're just going to go through how to answer that one. So A, the most reliable result has got to be Jordan. Jordan did 100 trials as opposed to 50 or 20 trials by Oscar and Andrew, so he's going to get the most reliable result. More trials means more reliable. Would you say the dice is fair? Okay, some of you went about this by just kind of looking at the numbers for Jordan, but it doesn't say just to use Jordan's results. So I would recommend that you add each of the sets of numbers together. So you'd add up Andrew's and Oscar's and Jordan's results for 1, add all their results for 2, add all the results for 3, and so on. And that gives you the values which are on the slide now. Okay, so all together, they rolled 18 1s, 29 2s, 33s, and so on. And that was out of 170 rolls. Okay, so we would expect the dice to be land on a 1 or land on a 2, 1/6 of 170 times. Okay, we'd expect 1/6 of the rolls to give us a 1, 1/6 to give us a 2, and so on, if the dice is fair. And if we divide 170 by 6, we get 28 to the nearest whole number. Okay, and if we look at what happens when 3 brothers roll the dice, 2, 3, 4, and 5 are pretty close to 28, so they're pretty much what you would expect to get. However, 1 is 18, 6 is 36, which is double the number of 1s. So this suggests the dice is not fair. Sorry, it's just jumped. You're more likely to roll a 6 than you are to roll a 1. So it's not a fair dice. Question 4. Okay, Venn diagrams. This was one of the questions that people struggled with. And on the whole, I would say the work on Venn diagrams is what people have found most difficult. Okay, so I'm going to go through this step by step. Watch this carefully. Okay, so first thing to do is to draw your rectangle with 2 circles overlapping inside. We know that the circles have to overlap because it tells us that some employees pack both clothes and food. So the 2 circles must overlap. Okay, we're going to label them clothes and food, and then we start to put the numbers in. Okay, it doesn't tell us how many go in the intersection. What it does tell us is that there are 48 people altogether, 22 pack clothes and 37 pack food. So if we add 22 and 37 together, we get 59, and there are only 48 employees. So to work out how many should be in the intersection, you take 48 away from 59, and that gives us the overlap. That gives us the number that pack both clothes and food, and that goes in the intersection. Then we need to work out how many pack only clothes. Okay, so this is where a lot of people go wrong. A lot of people just put 22 into the circle, and into the food circle they put 37. But if we add that up, it's going to come to a lot more than 48. So we need to take into account the fact that we've already got 11 in both clothes and food. So 22 employees pack clothes. Take away the 11 that are already in that circle. That leaves us with 11 in clothes only. Sorry, I've done it the wrong way around. Same thing with food. 37 altogether pack food. We've already got 11 in the intersection. We need to take those 11 away. That leaves us with 26 in the bit that's just for food only. Okay, so that takes us to question B. What is the probability that an employee chosen at random only packs food? So if we go to our food circle, we don't want everything within that circle. We just want the bits that are outside of the intersection. So it's going to be 26 people pack only food out of the 48 employees altogether. So 26 out of 48, and you can simplify that to 13 over 24 if you wanted to. Question 5. Okay, again, there was a few issues with this one. Neil has a box of 10 pens, 3 of which leak. Ollie and Thomas each take a pen from the box. So we're going to start by drawing a tree diagram to show the 2 selections. Okay, so we start with our labels. So first time round, we treat, although they probably may have taken the 2 pens simultaneously, we still treat it as 2 separate events. Okay, so the first set of branches refers to the first taking the first pen, second time are the options for taking the second pen. Okay, so 3/10 and 7/10 are the probabilities for the first pair of branches. The probability that it's going to leak is 3/10. The probability it's not going to leak is 7/10. And you could easily represent that as 0.3 and 0.7 if you prefer to work with decimals. This is where it's a little more complex. Okay, so if we concentrate on this branch here, if Ollie has taken out a pen that leaks, okay, there's only going to be 2 pens left in the box that leak, and there's only going to be 9 pens left in the box. So the fraction is going to change because there's only 2 left and there's only 9 pens left. Okay, so it's going to be 2 9s. Likewise, if the pen leaks the first time, there's still 7 pens that don't leak out of a total of 9 pens, so it's going to be 7 9s. We go down to our not leak. If the first one doesn't leak, there's still 3 that do leak out of 9 pens left in the box. And if the first pen doesn't leak, there is now 6 pens that don't leak left out of 9, so it's 6 9s. Okay, so this kind of probability tree diagram applies when you're not replacing the item. If they took a pen out and put it back, and then the second one took a pen out, the probability would stay the same. But Ollie's taking a pen out, Thomas is taking a pen out. So at one point there's only 9 pens left in the box when one of them takes it out. Okay. So we can then multiply along the branches to work out the probability of each of the 4 possible outcomes. So probability of 2 that leak, 3/10 times 2/9. Probability of the first one leaking and the second one not. Probability of the first one not leaking and the second one leaking. Multiply along those branches. And the probability that both the pens taken don't leak, we multiply the 2 branches at the bottom. So you always multiply along branches to work out the probability of leak, 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 not leak, leak, and not leak, not leak. Okay, so these are the 4 different outcomes. So we're asked what is the probability that at least one pen selected does not leak. Okay, and this is where we've got to be careful because it says at least one pen. So that could mean not leak, leak. It could mean leak, not leak. And it could mean not leak, not leak. So there's 3 different ways that we can have at least one pen not leaking. Okay, so in fact, the only one we can't have is leak, leak, because all of the others have 1 or 2 pens that don't leak. Okay, so we can add those probabilities up. So 21 over 90 plus 21 over 90 plus 42 over 90 gives us a total of 84 over 90. And that is the probability at least one pen does not leak. The other way we could do it is because we know probability always adds up to 1. You know, these 4 outcomes here, these 4 fractions will all add up to 90 over 90, which is 1. This pair will add up to 1. This pair will add up to 1. This pair will add up to 1. Probability always adds up to 1. So we could just take away the probability of both pens leaking from 1. So 1 take away the probability that both of them leak will give us the exact same answer, 84 over 90. Okay, and you could simplify that fraction if you wanted to. Okay, question 6. This one largely really well answered. Okay, this type of question, what they're looking for is the relative frequency. Okay, they're giving you the number of patients that are registered and they're giving the probability of someone in the UK having scleroderma. Okay, to work out the relative frequency, you simply multiply the frequency by the probability. So the frequency is the 7,000 patients, probability is 0.00001, which gives you 0.07. And that suggests that significantly less than 1 person is likely to have scleroderma in a population of 7,000 patients. So to the nearest integer, that is 0. Okay, so as I say, most of you answered that very well. Last question. This one, only a handful of you, I think, got correct. Okay, so buttercup is one of 23 types of ranunculus plant. I guess that's the Latin name. 14 types have yellow flowers, 14 types have 30 or more stamens, and 13 types have both yellow flowers and 30 or more stamens. So once again, 2 overlapping circles inside a rectangle. Okay, put in our labels. I've used YF for yellow flowers and 30 plus S for 30 or more stamens. Okay. So we're going to start with the middle, start with the intersection. We know that 13 have both yellow flowers and 30 or more stamens, so they go in the middle there in the intersection. Okay, this is where a lot of you go wrong. Okay, we're now going to put in the yellow flowers. There are 14 with yellow flowers, but we've already got 13 in our yellow flower circle. So we need to take away that 13, which leaves 1, which has yellow flowers but doesn't have 30 plus stamens. Okay, same thing with the 14 types which have 30 or more stamens. We've already got 13 inside that circle, so we need to take that away, leaving 1 that doesn't have a yellow flower but does have 30 plus stamens. Okay, it tells us there's 23 flowers altogether. we've only used up 15, 13 plus 1 plus 1. So the remaining 8 out of the 23 is going to go outside the circles because presumably they don't have yellow flowers or 30 plus stamens. Okay, and there's our Venn diagram done. Okay, question B. If a gardener has a plant growing in her garden, what is the probability that this plant has a yellow flower and has fewer than 30 stamens? So, as already seen, there's only one plant which has a yellow flower but has less than 30, because these 13 all have 30 plus stamens. So, it's only going to be one out of 23 altogether. Question C. Okay, this one, I think only two of you, got this one right. Joe picks a yellow ranunculus flower while walking in the countryside. What is the probability that the flower she picked has 30 or more stamens? She's picked a yellow flower, so this is conditional probability. Okay, what is the probability that that flower has 30 plus stamens? We know that she's picked a yellow flower, so our denominator is going to be the total of yellow flowers, and the numerator is the number that also have 30 plus stamens, which gives us 13 plants out of 14. Okay, and the way this is written here mathematically, the probability of 30 plus flowers given that it's yellow. Okay, that's what that slash means there. Okay, and lastly, question D. What is the probability that it doesn't have a yellow flower and has fewer than 30 stamens? Most of you got this one correct. And there's 8 outside of the circles out of 23 flowers altogether. Okay. So, add up how many you got right. Okay, I already have those marks. I've put some information about that in your email I sent out to you on Go for Schools. I'm obviously not going to publish who got what marks, except to tell you that I think the mean was 16. So the idea now is, once you've done your corrections, if you got question 1 wrong, do question 1 from this next set of slides. If you got 2 wrong, do question 2. If you got 3 wrong, do question 3. Question 4 wrong, if you got question 5 wrong, and so on. Okay, so the idea is that you get some more practice on the skills that you struggled with in the original assessment. If you got absolutely everything right, or very close to everything right, or you just want to do something that stretches you a little bit more, then there's an extension task on the last slide. Okay, I'm going to send out this PowerPoint as well, so that you can print it off if you want to, rather than having to pause the video and work from the video. Okay, thank you for watching.